Do you keep an eye on the timing?
Yeah. I've got Should we start?
Yes, I think it's time. Hello. Hello, guys. It's time to start. So this is the Bess session in Bangkok. Thank you for being here. So first of all, the not well. So please read it if you are still not aware about it. So we have started to send the blue sheets, so please sign them and ensure they are getting back to us at the end of the meeting. So we have now officially a new secretary for the Bess working group, which is Monkamanan. So thank you for your help, and please welcome in and welcome on board. So one point that has been raised by Martin, our AD, is that some of the drafts are still not using the new requirement language template. So please ensure that all of your drafts now are using this new flavor of requirement language template, which is referring to the RFC 8174, which clarifies the ambiguity between usage of lowercase and uppercase requirement keywords like must, must not, and so on. So please use this new template. So this is our agenda. It's not completely full, but it's still quite busy. So we will take a lot of time to review the working group status and documents. Then we will have some documents about EVPN OAM, some redundant multicast source for EVPN, a new service type interface for EVPN, secure EVPN, so virtual hub, and yeah, here is all that we have. Layer 2 gateway? Yeah, I will not read all. Okay. Okay, milestones. Unfortunately, we had no time to work on it, so it's still completely out of date, and we have to do some homework on it. But for the next IETF, I think we will be able to clean it up and set up appropriate milestones. So status update, we don't have any new RFC since last IETF. However, we have several documents that are in the RFC editor queue. 2 documents are still pending because of a misref. So the EVPN overlay is still waiting for the tunnel encapsulation draft, which I think is under Shepherd review now in IDEA. Is it one of you, Kyo? Okay. So please make it progressing fast. And we have another one, which is a prefix advertisement, which is a really important work for us, which is still missing the inter-subnet forwarding draft. So Ali, you have some homework to do because you still have to update the document based on the last working group last call. So it's very urgent to update it by the end of the week. The week. No, honestly, it's really urgent to close this work. So So in 3 months. And we have also the last MIB draft about MVPN and layer 2, layer 3 VPN multicast that are also in the RFC editor queue. We have also some documents under AD review, so the VPL seamless integration. So Martin, I think you have sent some comment on it, but you have not sent it to the list. And I don't think that you have received any reply.
Martin speaking. Yeah, so you just made me realize that I wasn't surprised of not having any reply, because I think you're the author, Ali, the main author. So I was just waiting on Ali to wake up. So
maybe in
3 months for the first line, so maybe in 6 months. Yeah. Thank you, Ali.
So DF election framework, I think Jorge has updated the draft. I'm not sure if you are happy with the update or if something is still missing.
Yeah, Martin again. Yeah, Jorge and I spoke about that. I'm happy with the draft, and I need to simply push the button and to send it to Lascon.
Thank you.
And I'll be doing the last one, optimized IR,
soon.
Yeah, according to Adrian's definition.
Thank you, Martin. And we have the explicit tracking and VPN draft, which is under IESG review. A couple of comments have been made, so I think there is we need some update of the documents to accommodate the comments from IESG. So we don't have any documents that are ready now to go to IESG. However, we still have some documents that are post-working group last call. So again, the inter-subnet forwarding. So I think this is the second working group last call on this one, and we still have some comments. So no, it's really urgent to update it. So please do it by the end of the month. We did also a working group last call on the Bess service chaining draft. We didn't add the full history on this one, and it seems that there is an old comment from Vim that hasn't been taken into account in the document. So yeah, the working group last call failed. I don't know, Wim, if you want to say something about it, if it's critical for you or not.
I think there were several comments which were rather critical for me to progress, because there is this work is, I think, very useful in a very simple service chaining. I think does a number of good things, but I think there is a lot of gotchas when you implement this, which should, in my view, be reflected in that draft, which are not there. I think the comments were mainly around those things.
I think your comments are really also, maybe it would be good to send an email redetailing or pointing to the email archives.
Yeah.
So to simplify the work of the author.
Yeah, okay.
Because yes, I completely agree that it's time to close this work, and there is implementation. We have also the VPLS multi-homing draft, so I think there is an update which is required based on your Shepard review. And the VPLS control flags, so the Shepard review has been done, the document has been updated, but we are waiting for the write-up. So I don't know, Mac, if you are in the room. Unfortunately not. So he has to provide the write-up, but at least the review has been done. And we have 3 documents that are ready for a working group last call. For the fast failover, I'm just wondering if it requires a new revision before we do the working group last call. I think there was a comment raised by, I think it was by Ali at last IETF that need to be taken into account before the working group last call is done. So when do you plan to do it, Greg?
Before after you remind me, I sent the proposed changes, so please will review it and get back. And if it's acceptable, then I'll submit to the updated version, and then we'll proceed.
Okay, thank you. So we have 3 new working group documents. So the flow DF election, the unequal cost load balancing for EVPN, and the virtual segments for EVPN. We have possibly 3 documents that are ready for working group adoption. The MVP and Yang, because we need to adopt it. There was already a poll that failed, but a new poll needs to be done. We are wondering if the LSP ping draft and the PIM proxy draft are ready for working group adoption. So if the authors are there, could you just say us if you still think that it's ready or not? Do we have the offer of LSP ping and PIM proxy draft here? So is your document ready for working group adoption, or do you still have some update to do before?
No, it's ready. It's ready to be ready for work group adoption, I mean.
Okay, cool.
Okay, this is Sammy. I'm a co-author on the draft Gene Bess EVPN and SPP.
Okay, thank you. And we have an ongoing adoption poll for the EVPN aggregation label. It runs until next Tuesday, I think. Not this one, but the week after. We already have a pretty good level of support on this draft, but don't hesitate to raise any concern or raise also your support on this draft. The working group document status. We have some issue to get some progress update on the working group documents, especially when we have some sessions like this one where there is only one working group document update presented. So what we would like is to better track these documents and make them progressing faster. So what we are proposing is that each editor of a working group document send us just a couple of lines periodically about the document status. What we need to ensure, what we need to get is what is the status of the document? Is there what are the pending actions, and especially is there any blocking point where you need some help to make the document progressing? And we want also to get your timelines. So we completely understand that everyone is busy with a day-to-day activity, but please set timelines and make all your possible to get this this milestone achieved.
AC Wyndham Cisco Systems. Speaking as a working group chair, you really think you're going to get the editors to do this on a bi-monthly basis, or is this just?
We would love to, but I think we will need to chase the editors to do this, for sure. So we would love to get this every 2 months, if possible. So this means before each IETF meeting, but also in between. So possibly in January, March for IETF, May, July for IETF, September and November. Okay, it's not a lot of work, just 2 or 3 lines telling what's your plan and so on. So it will help us to have the status on what is going on, and we are also able to help you if there is something that is blocking, or possibly you don't have time to do something. Yeah. So the question is, do you think it's possible on your side, or do you think it's useless? What's your opinion?
Martin speaking. I'm not an author, so that's easy. I'm discovering that proposal, so it doesn't come from me. I think that's a good goal to have. And I would like to encourage authors to participate as much as they can to that initiative. I think we can discuss the frequency and so on, and what you really expect. But that falls in the discussion of the usefulness or uselessness of milestones, and how do we track alternatively working group progress, more like a project management type of doing things. So I think it's worth a try, and I'll be delighted to see the output of that initiative.
Loa Anderson, we are doing something similar in MPLS, though we request reports for each meeting, not like this bi-monthly stuff. Our conclusion or our understanding of the process here is that if you have a document that where we don't have any problem, this is very easy. We get the reports like 4 or 5 days before the meeting, and we can put them on in the slides. The documents that we have problem with, nothing happens, no reports, no nothing. So I think you will get into the same problem here. So if you have a rather small number of problematic documents, then you can interact with 1 or 2 of the authors to get reports kind of implicit in mail responses, and you can kind of create a 2-liner yourself, which we are doing in MPLS sometimes. So I don't think this is too much work for the authors, but you are actually creating a lot of work for yourself.
That's true.
I agree with Loa. I think that will add a lot of additional work on your side, but that might be part of being a chair. And I think the first bullet point of the goals is the more important one, so that you have a better vision on the target date and the readiness of a document, so you can better track that.
I should be fair also. In MPLS, it's not the working group chairs really that actually take the burnt of this. It's actually Tarek that does all the work prior to the meetings to get all the reports in. So you need a very active secretary if you want to do that.
Okay, so let's try, and then we'll see and adjust if there is something going wrong. So we
PE connecting to the receivers. There's this term called the single flow group. It's basically a multicast group address where all the traffic, no matter where it is from S1, S2, or even S100, is basically for the same flow, same content. Also, the S1 or S2 could be the same address or not. There are two modes of operation here. We could have warm standby or hot standby. And in case of the warm standby, we have this primary upstream PE1 and that backup upstream PE2 here. So for the warm standby solution, basically the PEs connecting to the redundant sources, they will do an election to decide which of the PE will be actually sending traffic into EVPN. And notice that it's possible that two redundant sources, they actually may be sending traffic into the same PE. In that case, the chosen PE will actually decide on which of the attachment circuits it will accept traffic and forward. So that's the warm standby solution. The hot standby solution is that both PEs connected to the sources will send traffic into the network, but each downstream PE will independently decide from which ingress PE's traffic will be accepted and forwarded onto the end receiver. So here are some very high-level details on how warm standby works. If you look at the picture, we have upstream PEs, PE1, PE2 there. They are configured to know that group 1 is a single flow group. And notice that the sources could be connected to different BDs or not, connected to this different PEs. So for the upstream PEs to let each other know that they are connected to the redundant sources, we're using this SPINZ route, selective PINZ AD routes, and indicating that this is for a single flow group, and they are imported by all the PEs, and the upstream PEs, they will receive the SPINZ route from each other, and they will do a DF election. Notice that traditionally the DF election is using the Ethernet segment routes, and the purpose of the Ethernet segment routes is to let each other know that these PEs are on the same segment so that they will do the election. Here, we're not using Ethernet segment routes, but we're using the SPINZ routes to let all those upstream PE know that these are the PEs among which you want to do the election. So again, the P1, P2, they will choose one to send accept traffic and send into the network. And in their forwarding states, they will add some RPF checking, and so that on the chosen forwarder, if you have multiple attachment circuits connected to those sources, then only one of the ACs will be used to accept traffic. And for hot standby, if you look at the picture, we have the red and blue flows. Both PEs will receive the traffic, and both will send into the EVPN. And the downstream PEs, they will get duplicate traffic, but they will be able to tell which copy of the traffic they need to forward to their receivers. Here, the ingress the upstream PEs will signal to the downstream PEs that certain groups are single flow groups, and they also they will use the SPINZ routes for that purpose. In the SPINZ route, they will identify the Ethernet segments on which the sources are, so that the downstream PE can use the SPNZ routes to make each one to make an independent selection on which Ethernet segments to accept traffic. For example, if you look at the PE1, it's connected to two Ethernet segments. On PE1, it's connected to one Ethernet segment. We call it SES1. On PE2, it's connected to SES2. Actually, they were no. They both are connected to two multi-home Ethernet segments. So in each SPNZ route, they will list both segments identifiers. And then downstream PE3 will see that, okay, the G1 is a single flow group, so I will decide that I want to accept traffic if it's coming from ES1 instead of ES2. And the data packets will carry the ESI label that identifies the incoming Ethernet segments. Notice that this is already existing procedure in the EVPN multi-homing split horizon. The data packet already carries that label, and we are only adding additional forwarding semantics so that if the traffic is coming from the expected source segments, we will accept the traffic. Otherwise, we don't. So that's the basic idea. I'm going to skip the details here. We want to seek your feedback, comments, and in particular, how to encode G-source identifiers. Yes.
Okay. And Jeffrey, a couple of questions. First, on the active standby.
Yeah.
Basically, the previous slide, warm standby. With the warm standby, basically what we are doing DF election for a source for a S, G for a specific group.
DF election for a particular group among all the upstream PEs.
Right.
Right. Yeah.
Given that we have the capability to do, we've extended DF election to do per flow basis. I'm wondering, basically, can we leverage that per flow DF election mechanism in here, given that the DF election in here is for the ingress traffic. That is one comment. If we can leverage the per flow DF election.
The reason here we need to use this SPNZ routes is to let the PEs know that this particular group is a single flow group, because not every group is a single flow group. There are other groups that are not for the single flow group at all. So we need to have some indication that saying that this is a single flow group. So we choose to use SPNZ.
Right. But basically you need to identify the group and say for here is a group.
Yes.
And for this one, categorize this group as SFG.
Yes.
When you do that, you can do the same thing that, okay, for this specific group, run the DF election. I think the difference, the reason I'm saying that it needs to be extended, the current DF election, is because the current DF election is limited to a given Ethernet segment, whereas this can expand across multiple Ethernet segments because it can sit on different ESS.
Right. Today's DF election is basically use Ethernet segment routes to
Right.
know the set of PEs to do the election from. And here we use the SPNZ route for that purpose. Otherwise, it's the same.
Right,
Yes.
and there was at certain point there was a notion of the hierarchical ES that spans across multiple ES. So
Yeah.
that maybe should be considered. And on this front, still currently up to this point, SPIMC were used for the on the receiver side. When the receiver indicated they have an interest, we were using the SPIMC to send the
SMAT route is on the used from the receiver side, but SPNZ route are sent from the upstream PEs, and we are just using it for the purpose of identifying the.
Oh yeah, SMAT. Okay.
Yeah.
And on the active.
We will need to let time to the other comments as well, because we may be out of time.
Okay.
You
all
can
right.
follow up offline.
All right.
Yeah.
Stig Venas. So does this solution work for SSM? It wasn't quite clear to me.
Here, it does not matter whether it's SSM or not. Basically, we're just saying that if you have a group and you're sending traffic into that group, then we consider that it's for single flow. So in fact, for each source, you can consider that it is SSM, but it's just that when we consider that these two are actually the same, we're using the star G concept here.
Okay.
Yeah.
Yeah, I would say this looks sort of reasonable to me. My only concern is maybe that it requires, of course, a certain deployment, that you choose your group addresses. I mean, that the redundancy flows use the same group address. So I was wondering if you have thought about some way, instead of signaling that, you have maybe two different S-Gs that form like a redundancy group or something like that.
We thought about that. In fact, initially we thought S1G, we would advertise S1G1 and S2G1 SPNZ route.
Right.
But we figured that you have those two routes with different route keys. It makes it harder for the software to group them together. So we said using the star G. And then Manakana actually has a good point that you can just use source prefixes. For example, S1, S2, they are different, but you use advertised SPNZ route using S/prefix length. That way, you still have the same route key, but you can have you can use the same group for different flows.
Okay. Yeah, so I get it's it's sort of like a trade-off between complexity in the signaling,
Yep.
and whether you can have some requirements for the
Yes.
S-G choices.
Yep.
But yeah, I see how this makes it easier. Sure.
Thanks.
Unfortunately, we are out of time. Sorry. Next speaker, Ali? Or is it you? Okay.
So in this presentation, we are defining new service interface type. So before going to what exactly it does, maybe it's good to talk about what exactly we need or what are we expecting. So some of the deployments, they need to have multiple subnets within single bridge domain. When we say multiple subnets, so they will be differentiated by VLANs. And now if you see 7432 defines 3 types of service interface, and these 3 types are VLAN based service interface. And here we have 1-to-1 mapping with respect to bridge domain and VLAN. VLAN bundle service interface. So here we have multiple VLANs within a bridge domain, but if you see, traffic is expected to be coming tagged, and that's how we are able to get the right port. And in case of VLAN aware bundle services, we have multiple bridge tables, but the actual requirement was to have single bridge table and still having multiple subnet. But one more question comes here, that what is the motivation for anyone to do that? So one of the motivation will be simplicity, because if you want to have 100 of subnets and if you end up having 100 IRB interface, so basically you have to have those many configuration and you have to manage IP addresses, so many other things. And just to understand the problem statement, so if you see here P1 and P2, they are multi-homed, and they are multi-homed all active. And if you see, I'm showing different color of subnets here in the same ES. So if P1 learns about MAC of H1, and today if we just do when we send MAC route, so P2 will receive the MAC route for MAC 1, and P3 will also receive the same MAC route. Now, let's think about the case if traffic is coming from the IRB interface. So if you are getting traffic from the IRB interface, you don't have any VLAN tag there. How are you going to associate that which subnet basically MAC 1 belongs to? Because P2 doesn't know about it. Today, when we send the MAC route, we don't send Ethernet tag. And similar way, it's for MAC 2 also. Now, one of the question which comes, why can't we just send the ether tag in the MAC route? So if we do so, what is going to happen if P1 sends MAC route with ether tag? P3 thinks that the downstream P, they are operating in VLAN aware mode, whereas it is not. So it is going to create confusion there. So the solution for this will be, so if you see what exactly our requirement is, we want to make sure that when P1 is sending any MAC route, the multi-home peers should be able to know that which AC it belongs to, which AC this MAC route belongs to. But P3 doesn't care. So this information is supposed to be used by only multi-home peer. And to do so, we are using a new extended community. And this extended community is called, so it will carry the attachment circuit ID. And this attachment circuit ID extended community has to go for unicast, MAC IP route and route type 7 and 8, which is multicast. So just to go back, why exactly we need it for multicast? So if you see, let's say host H1 sends IGMP join, and IGMP join reads to P1. P1 will be able to create correct multicast state, but when it syncs the route to P2, P2 only knows about S, G, but it doesn't know that which interface actually join had come from. And that is the reason that even for multicast routes, we need to send this extended community. And attachment circuit, which is, since when you originate MAC route is not only for the multi-home peer, whereas it goes to remote Ps as well. So remote P must ignore attachment circuit extended community, whereas only multi-home peer should be using it. So with respect to control plane operations, so let's think about what is going to happen for the local route. So when P learns local route, it must attach new extended community with MAC route, and same thing with multicast routes, which is route type 7 and 8. At the remote side, so for the remote route, you could be one of the two roles. Either you are remote P or you are multi-home peer. If you are remote P, you must ignore it. In the MAC route, you must not ignore the MAC route, whereas you must ignore the extended community information. And remote P is not going to get multicast route. So for multicast route, there is nothing to do with respect to remote Ps. For multi-home P, for multicast routes, you must set your S, G or star, G association with appropriate subnet. And even the same thing for MAC route. When you learn any MAC, you have to create association with correct attachment circuit or subnet or VLAN. For data plane operation for non-multi-home peer, so with respect to non-multi-home peer, there is no change. Whatever procedure has been defined in 7432, it will be still, it remains same. Data plane operation at multi-home peer. So now, there are two ways. If traffic is coming from the CE, nothing changes. Whatever is a procedure has been defined in 7432, it remains same. And unknown unicast packet must follow the same procedure what has been defined in 7432. And with new defined service interface type for known unicast packet, now when we do MAC lookup, we are going to get port plus VLAN info. And with respect to multicast traffic, known multicast traffic, we are going to get the appropriate AC where this traffic has to go out. Oh, that's it. So any question?
Stefan Nikowski from Orange speaking as working group member. What is the value compared to the VLAN-aware interface type?
You mean to say that?
Yeah.
Basically, the gist of this is this solution is intended for the hardware or low-cost hardware that have limitation that they cannot have one bridge domain per subnet. Because up to this point, we're talking about VLAN-aware bundle service that we can allocate one bridge domain, one bridge table per subnet. There are hardware with that limitation, and for those hardware, we are saying, okay, you can use one bridge domain, use it for a lot of subnet. However, there is a caveat, and that didn't come across clearly. The catch is, if you do that, then the MAC addresses needs to be unique across all the subnets, which poses the requirement. Basically, that is very good for the managed CEs, that the operators can manage their MAC addresses. So for those cases, and this is the requirement that have come to me, that the operators saying that we can manage our CEs, we can make sure that the MAC addresses are unique. Can you solve our skill problem? And this solution is for that.
Thank you.
Sure.
Yeah, I do have one question. Sorry, this is Sammy. I have one question. What about bump traffic from remote PE? Are you going to send it to all VLANs?
Bump traffic?
Yeah.
So yeah, it will follow 7432.
No. So you have one bridge, okay? And you have one interface connected to the bridge, right? On that interface, you have many VLANs.
Yes.
So now you receive bump traffic, okay, from the remote. So are you going to send one copy for every VLAN on that PE, on that interface?
Okay. So this solution is for the IRB, for the unicast, for the IRB. Basically, when the packet comes through the IRB interface, you just send it to the proper AC, right? And
But the AC here has multiple VLANs, right?
the AC is in here defines a VLAN. Each VLAN is an AC.
Okay, but which AC? I receive
so are you talking about the bump?
Because you said
bump traffic or
no, you said multiple subnet, right?
Multiple. So for IRB, it's very simple.
I get an ARP request from the remote, right? How will I figure out which VLAN I have to send it? The remote is not sending me a VLAN.
Very good. So this is for the IRB case that you terminated at the IRB interface. You don't pass the ARP from one PE to the other. In the IRB case, the ARP gets terminated locally.
So you mean you proxy it?
No proxy. This is with the IRB, every PE terminates the ARP because the bridging is done, the inter-subnet, right, is the inter-subnet is gets routed.
I assume here's the IRB. You'll be a gateway of all subnet on the IRB, right?
Yes. Anycast gateway.
You have multiple.
Right.
Okay. Anyway, we can take it offline.
Sure.
Thank you.
All right.
Thank you. secure EVPN?
All right. This draft is about how to secure connectivity among the end station for VPN. Starting with the problem statement that, as we know, EVPN has become very prevalent solution in the DC, SP, and enterprise network. And for DC and enterprise application, especially when we talk about the DC interconnect and enterprise connectivity over WAN, customer want secure connectivity with EVPN when you have that connectivity over internet. What are the requirements? The requirements is to be able to do protection of the tenants layer 2 and layer 3 data and control traffic by IPsec. So both data and control traffic at both L2 and L3. Protection of unicast, tenants unicast, and multicast data traffic. Using BGP to do point-to-multipoint signaling to set up point-to-point IPsec SA. And that is for the scaling purposes, because if you're going to use IKE protocol, IKE is a point-to-point, then basically you're gonna need, in terms of the message exchanges, is ON square. Whereas when you use BGP point-to-multipoint signaling, you reduce that scale to ON. Be able to support different level of granularities, which I get to the next slide, and also be able to support either a single IPsec policy with a Diffie-Hellman group or multiple policies with multiple Diffie-Hellman groups. Now, what level of granularities do we want to support? We want to be able to support setting up an IPsec session, SA, among the PEs for aggregating all tenants' traffic. So basically think of it as a single IPsec SA between a pair of PE. And that tunnel aggregates all the traffic from all the tenants. That's the highest level of granularity. Then you go to the next level is be able to do it on a per tenant basis. To set up a IPsec tunnel per tenant, and if the PE supports 100 tenants, that means you need to set up 100 such tunnels. Then you go down to the next level of granularity for the EVPN. We have this notion of the subnet. And a tenant can have multiple subnet, multiple VLANs. So be able to do IP sec tunnel on a per subnet basis. And you can go down the list that, okay, in case for a tenant has some workload and I just want to secure connectivity for that, for a pair of workload, I need to be able to do that, and that is done for a, be able to do it on a per IP address. Same thing if you use a, if the workload is identified by MAC address, I need, or I like to do it based on the MAC address. And also, last but not least, be able to do it on a pair attachment circuit basis. Now, solution overview. This is basically, we want to set up a secure control channel, which means we like to set up a BGP session over IPsec tunnel between PE and RR. And between, so PE and RR, we want to have that secure control plane. And once we have that, then we can use that to do point-to-multipoint signaling. and be able to use that channel between the PE and RR to send the parameter, the IPsec parameters needed to set up a tunnel between a pair of PEs. So between a pair of PEs, we are not doing any pairwise signaling channel. We are not using IKE, but the security association is set up between a pair of PE. And that reduces the, as we mentioned, number of the message exchanges from ON squared to ON. And when a PE first comes up and wants to set up an IPsec SA between itself and each of the interested remote PE, it basically generates a Diffie-Hellman pair for each of its intended IPsec security association. And then it distributes these information, Diffie-Hellman public value along with nuance, to the other remote PEs via the RR. Each receiving PE then uses these Diffie-Hellman public number and corresponding nuance in creation of the IPsec SA pair. Just a quick note in here before getting into a bit of details that this is there is a framework draft that goes with this draft, and that framework draft is called Controller IKE. Got presented in the last IETF and at the security working group, and that is basically sets up the framework of how to when you have a controller, how you can leverage that controller to do point-to-multipoint signaling. And one of the main area that is covered in that framework draft is the rekeying. If you need to do the rekeying, what is the procedure for rekeying to do it in a via the point-to-multipoint signaling as opposed to point-to-point. So this draft builds on that, and basically in context of the EVPN and other VPN solution, it says that if I want, it defines different level of granularity, and it talks about what information you need to send with which of the routes to achieve the level of granularity that you need. So in terms of the encapsulation, it has covers two types of encapsulation. One IPsec encap in transport mode without the outer UDP header, and then another one with outer UDP header. The reason for these these two type of encapsulation is when you do IPsec encap and you do it without the outer UDP header, then the question is, how do you do if you want to do load balancing? How are you going to do the load balancing on a per flow basis, because your entropy was used to be in the source port, which is no longer visible. And if you want to do the NAT, how do you do it? And that's why we have both of them. And the second one. You have to speed up. Oh, you're almost out of time. Okay. So this is the encap with the without the outer UDP header, and the next one is encap with UDP. Both of these encaps are standards, okay? And we are using the standard. The second one with the UDP has two UDP header, and that can be the optimization of this is for further study. And this is the this is my last slide. This table basically covers what are the different level of granularity for what VPN solutions, which of them, what route we need to send for each level of granularity, and which level of granularity is applicable for what VPN solution. Some of them are not applicable, like a per MAC per IP is not applicable for VPLS. Okay.
This is Linda Dunbar from.
Quickly.
Okay, so I have many questions, but just want to clarify question. So here you're talking about between PEs, right? Because we have a draft about SD1 is really about the CPE and also the zero-touch provisioning, like require a CPE to have private addresses, private port. So do you see this similar? Because we also use that BGP to advertise the IPsec SA properties, plus the net properties as well.
So although I use the term PE in here, but this is, you can refer it as a customer PE.
Okay.
C-PE. I think Eric in his draft, he refers to it as C-PE. I didn't want it to, if such clarification is needed, we can do it. But as you can see, these are the basically behaves in a as a PE, even though it is in a customer admin domain. And so you want to call it C-PE, that's why.
Okay, so, but...
I'm sorry, but we are out of time.
Okay, so we can talk more.
Sure.
After.
Yeah, one comment, speaking as a working group chair. So you mentioned the draft from Ron and Eric, which provides a similar solution.
No. Actually, the Eric's solution is completely apple and orange. He's talking about the only similarity is the term C-PE. Everything else is different because he's and they're trying to solve different problem. Okay, this is trying to say that I am going to be using the BGP, and how am I going to be using the BGP, which is point-to-multipoint signaling, to set up a point-to-point association. That's the gist of this draft. That is not addressed in Eric's draft.
Okay, but my point is we don't want to have two solutions. We need to find something to secure VPNs, whatever the VPNs are, L2, L3, and so on.
So maybe we should come up with a better name to clarify exactly, what it is, or at least the title of it. But the two solutions are completely different.
Can I make a quick comment?
Very, very quickly.
Run.
Keyur Patel, Arcus. There is a separate work going on an old VPN, at least for L3 VPN, IPsec RFC, which is already out there, which needed to be refreshed as part of tunnel and caps drafts. So we're working on it. We should chat offline and see if we can make it generic. You're making this on a tunnel and cap. So one thing to actually clarify, which your draft doesn't, and we can take it offline, is how do you prevent the security profile getting leaked out of inter-AS? You truly do option ABC. I'll take the answer offline.
Okay. There's an answer to it.
Okay. Thank you.
All right. So just a quick comment on a previous draft. I'm going to request for comments on the previous draft on the mailing list, because I think it is important to progress that one quickly, and I'd like to take it to the working group. So this is a draft Havanet spoke in BGP VPN. Is interesting. My draft gets presented by someone else, and I'm presenting someone else's draft. Oh, yeah. So, history. It got presented in, first it got presented in the IETF 94 3 years ago. And we updated it last year with the bump procedure. Jeffrey helped with that section. And it is in pretty good shape right now. And the draft is basically, in a nutshell, is optimizes the learning in leaf nodes of a data center, aka spokes. So currently, for a data center, a given leaf nodes needs to learn all the MAC and IP addresses of the of the tenant and or end station in that data center. What this solution does, it limits it to that node only. So this solution is intended to scale the forwarding tables. Changes from the previous Rev. Rev 0 we used a local bias method for the split horizon filtering of the BOM traffic. And we basically, in order to identify the source spoke in local bias applies to IP. So if you bring it to MPLS, the question is, how do you identify the, what mechanism do you use to identify the source PE? And we use PE distinguisher label. And in this Rev, in addition to that, we added one more mechanism to do that, and that is basically using a domain-wide label or a global label in that domain, which basically, for all practical purposes, looks like, acts like a VNI. This draft has been around for a few years, and I think it is ready for a working group call.
Any comment? Who has read the draft? Okay, very few. Who plans to read the draft? Okay, a few more. Thank you.
All right, thanks.
Hi, my name is Luc-André Burdet with Cisco, and I'm here to present draft Reset Bess EVPN L2 Gateway Proto, which is about introducing a new load balancing mode to EVPN multi-homing. So what are the requirements? To support L2 access protocols in EVPN networks, for example, legacy data centers, which are running this long list of STP derivatives like STP, G8032, MPLSTP, MSTAG, and so on, into an EVPN core network. The EVPN core PEs are generally agnostic of what's happening in the access. But one thing is certain in these use cases is that these EVPN PEs do know that the access is running an L2 protocol to break loops, which leads us to the actual requirement list. To support these L2 access networks, the solution must do optimal forwarding at L2 and L3, and support Anycast IRB while providing fast convergence and scalability. If we go through an overview of the existing two modes of load balancing. First off, all active. All active per 7432 creates an ECMP at, if you look at the picture on the right, creates an ECMP at P3, which in this topology of the switches A to D below would create an ECMP towards the wrong PE for some of the traffic. The second issue is it creates isolated switches for the L2 BUM traffic because of the blocking on, for example, P1 in this case from the DF election. And third of all, the TCN or the propagation of TCN BPDUs is blocked by the SHG filtering, the split horizon filtering. The second existing load balancing mode, single active, similarly creates isolated switches. So it creates network segments based on the blocking in red here on PE1. And also, so the TCN propagation in single active case is actually blocked by two things. both by the port state, the blocking state, and by the ESI split horizon label. So the new mode, which we've coined single flow active, what this mode does is we reuse the same, so we create a peering between P1 and P2 using the same ESI. So all the Ethernet segment procedures still apply, such as sync and mass withdrawal procedures. To implement this, we have an extension to the ESI label BGP extended community. To single this new load balancing mode, we carved up the flags of ESI label into borrowing 3 bits. Currently, bit 0 is all active and bit 1 is single active. So by defining a subfield, we now have a single flow active mode and potentially other load balancing modes in the future. With this mode, the peering PE must now not perform the split horizon filtering to allow the L2 access protocols to communicate BPDUs in some of the access protocol cases. And so more importantly here actually is the peering PEs have to enable MAC mobility procedures within the same ESI. From a remote PE perspective, for a remote PE such as P3 here and facing P1, P2 in the same ESI in single flow active mode, P3 has to disable ECMP, disable aliasing at both L2 and L3 and operate more in an active backup mode, and potentially should pre-program the backup mode per MAC entry. I'll say a few brief words on TCN. The peering PEs, P1, P2, when they receive a TCN from the L2 access network, they both consume it, so do a local MAC flush based on this TCN, but also propagate it to the peering PE via a dedicated pseudowire, for which we've actually looked at EVPN VPWS, which is quite well suited for this on the untagged interfaces, or untagged ACs, sorry. And then basically relay this TCN that was forwarded on the EVPN VPWS back into the access for consumption by the other access network segment. We've also considered PE3, what PE3 should do with the TCN that's received and consumed at P1, P2. So P1 and P2 will map this TCN into an extended community which has increase in sequence IDs, essentially a MAC flush sequence extended community in the EVI EAD. So that's the end of my presentation. I think the next steps are essentially asking the working group for comments and feedback on this. Thank you.
Good afternoon. My name is Sami Boutros. I'm presenting an update for the Bess EVPN for Geneva. Yeah, the draft was originally presented in IETF 99 last year. So in this draft, we are adding a new tunneling cap. EVPN already supports multiple tunneling cap. So we are adding Geneva as one of the tunneling cap for EVPN. And Geneva as a tunneling cap, it's similar to VXLAN, but with the capability of adding option TLV and carrying as well different layer 2 protocols other than Ethernet. So, so what we are specifying in the draft is a way to communicate in control plane what kind of options are going to be included with the Geneva tunneling cap. So those different options can be carried with in data plane now with the Geneva tunnel as pair the control plane. So the control plane as well could allow the PEs to negotiate what kind of option should be present based on the capability of each PE, accepting the reception of certain option, but not accepting others, for example. So this is was a quick background or a history on the draft. New tunnel type in EVPN. That tunnel type has some capability related to options. So this is how we can communicate those options in the EVPN BGP control plane. Since the original draft that was presented last year, we added few extension here or couple of extension. We updated more the section on the negotiation of those options that can be carried in data paths with the Genève tunnel. And as well, we defined a new option TLV. We called it Ethernet option TLV. So that Ethernet option TLV allows the data packet to carry in the Genève tunnel header an indication that the traffic is bump traffic. And as well a leaf indication as well. And furthermore, an option source ID, a 24-bit source ID that can encode an ESI label for split horizon procedure as defined by RFC 7432. So I think, yeah, this was the changes mainly to the draft, and I think we believe that the draft is ready for our group adoption. So, so we're asking the chairs for that.
Go ahead, Keyur.
Thank you, Keyur Patel Arcus. I've gone through the draft. One meta comment I have was the same one for Ali also, that at an eBGP boundaries, when the next hop changes, you need a text in here that says that the tunnel encapsulation cannot be carried beyond that unless and until it's configurable. Because if you signal a wrong tunnel encap beyond your domain boundary, forwarding may not be able to actually work.
Agreed. I think, yeah, definitely the draft is limited to one boundary and handling, different, but because we can have different encap as well in the different boundary MPLS and so on. So that will be addressed. I don't think we'll address it within the scope of the draft, but we are thinking maybe another draft can address that scope, right? But which is outside the boundary. You are talking about multiple boundary for multiple domains. Sorry, for EVPN.
Keyur, don't you think that it is agnostic to the tunnel type? This ability to...
Well, all I'm saying is when the next hop changes, the tunnel type is a function of a next hop between two PEs. When you change the next hop and when you announce it out, the forwarding may not work if the encap attribute is gapped.
I fully agree, but my point was just, is it something that must be addressed in the tunnel encaps draft, because this is something that is generic?
We can only add advisory notes in the tunnel encap draft, which I can, but your draft has to be very explicit about what the boundary is, or at least carry something that says that if it goes beyond an administrative domain, it is upon operators to ensure that the attribute is dropped.
When the next hop changes, you are talking about a different tunnel, right? So it cannot be the same tunnel.
Does it make sense?
Yes, it makes sense, but I think this is something that also needs to be mentioned in the tunnel encapsulation draft.
I'm more than happy to cover that.
Sam, with NVO3 working group chair hat on, could you also solicit comments in the NVO3 working group? And the second thing I think we discussed, but we can take it offline.
Sure,
about
yeah.
The inter data center part.
Sure, yeah.
Okay.
Sure, Sam. So you want me to send the draft to the NVO3 working group as well, right?
Yeah, just soliciting comments I think is good, because Genève being the approved NCAP for the DD.
Sure.
Data plane. So
okay, we'll send it there too. Thank you.
Okay, who has read this document? Okay, very few. Patrice.
I'm Patrice Brissette, Cisco. I'm here to present you the EVPN multi-homing, port-active load balancing. So we already talked about a few of them today. I think it's just one more. So we have all active, we have single active, we have single flow active, and now it's port-active. Okay. So we keep adding. All right, so this is very simple. Basically what we want to do is with EVPN, we call it also, many people call it EV lag. We support multi-homing. We want to make sure that we can almost take over all the legacy technologies. So in the past, we're doing MC lag with ICCP base. And by, I was reading the old RRC on this, and we, actually we made ICCP required target LDP session, right, to work. So, so the idea here was say, oh, that's not good because there's a lot of new encapsulation that we're using that will not use target LDP session. So therefore, we need something to replace this work. So therefore, we came out with the active standby concept for the well, what we call also per port load balancing. So it's very simple. So we are doing the same thing pretty much as before, but we make it a bit more simpler. With ICCP, there was a lot of negotiation to make sure we can bring the bundle alive on one side and standby on the other side. So now what we are saying is, let's configure it kind of manually on both sides, make sure that all the C system ID, port priority, and so on, they are the same, so the bundle can come out. And we just use EVPN to say which one is active, which one is standby, and we are doing this per ESI. So that can work for any layer 2 service, or it can also work for layer 3 service. Or if you want to get it to a B, or actually you can also do it for L2 and L3 if you want to run different sub-interface. So the main advantage, okay, and I think I just mentioned it a bit earlier, but so we can, so we displace totally ICCP-based MC lag. We can run it over like VXLAN or SRv6 where targeted LDP do not really exist. It's fully compliant also with the RC 7432. We're not changing anything that we came out from the past. We are just making use of EVPN to do the same thing that MC lag is doing. That's it. Comments, questions? Next one. All right, that's my longest presentation at IETF. Look at that. So EVPN Yang, one slide. So we updated V06. I know there's comments from you to be answered as we discussed at the beginning, and from Sasha as well. So we'll do this and we'll update it as fast as we can so we can go to last call. Comments, question? See, 5 minutes. Now you're right on time on the schedule.
Good afternoon, everyone. My name is Qing Wu. I will present this topic. It's about the YAML data model for VPN service performance monitoring. So this actually is a new draft we present. We posted in Bess working group. Motivation we write this draft is right now we have a bunch of the performance method or protocol that have been proposed for Ethernet traffic, RP traffic, and MPLS traffic, such as RP traffic, we have TWAMP WAMP protocol, and we also have a bunch of the performance metric has been proposed for delay and packet loss and jitter. And MPLS traffic, we have MPLS loss and delay measurement. For Ethernet traffic, we have Y.1731. But right now, all of these performance measurement actually we usually use actually in the underlying network. But how we can expose this performance measurement result to the overlay to the operator or customer, allow the operator to re-optimize the network. That's something we really want to go for. We think we haven't seen any work to discuss this. So typical use cases we list here actually, for example, we want to set up one VPN service with 3 sites. So from customer perspective or from operator perspective, they don't care about what is underlying technology you are using, but what they care about is, for example, the one-way delay between the site or packet loss within the site. So we can actually set the source in the underlying network. We can actually export these kind of performance measurement results to the overlay. And when this is possible, actually service provider can use these performance measurement results to re-optimize the network. For example, you can do increase the bandwidth for some of the tunnel, or you can actually do some switch from the primary tunnel to the backup tunnel. So to address this, actually, what we propose actually to leverage the RTOS defined network topology model. Actually, this network topology model can be used describe the multi-layer topology. You have underlay, on top of that we have overlay. We can actually build multiple overlays. So the idea is if you actually monitor the VPN service, actually you can build the service topology on top of this network topology. Also, you can actually use this network topology model to describe the service topology information, such as any HubSpot relationship between the site, and also you can actually link the performance measurement result with network topology model. So in this way, actually, we can establish the link or relationship between overlay and underlay. So here we give an example about the relationship between the overlay and underlay. Actually, you can map the site information in overlay into the underlying network, like the network device in the underlying network. So we can actually define the source for the performance measurement data. Actually, this data actually can be measured in the underlying network, and these can be exported to the overlay, and also you can do some aggregation or to calculate this end-to-end performance measurement results using some mechanism like a PCEP or AirMapper solution. And then you can feed this data into some data source like a management system or network device. And with this data resource, and then we can actually use netcov YARN based mechanism like a YARN push notification. You can subscribe such kind of data you are interested in, and allow the network device or management system to publish these results to the overlay, allows operator to base these kind of results to re-optimize the network. In addition, we can allow the customer actually can do some query using some RPC model to do that. So the example we give here, actually, you can see, I don't want to expand detail. If you are interested, we can discuss this. So it's a new draft with solicited comments from this working group. Yeah, that's all. Thank you.
Thank you. Who has read this document? Okay, thank you.
Okay, thank you.
So I think we are done for today. Thank you. Just one last comment to Patrice, if he's still there. Okay, about the port active draft. This is the second presentation. Do you consider to ask working group adoption for this draft, or do you think it's not ready yet?
So either today or on the alias, we were going to, yeah. I think it's -02 or -03 now, right?
It's -1, I think.
-1?
This is the second presentation. That's why I'm wondering why you are not asking for working group adoption.
No, so I think it's a -01, but it's first present. It actually went straight. Did he do this one already?
It was presented in London.
Okay. But the answer is yes.
Okay, thank you. So thank you all, and see you in Prague.
Yeah, well, before you leave, if anybody has a blue sheet, could they bring them to the front, please? Good. They should have gone around. They were.